With this particular sequence, I have a first term, I have a last term, and I have three missing terms in between. I need to figure out what those missing terms are. Those terms are called means. But because there's multiple ways to do a sequence, I need to be more specific. I need to say that I'm looking for this sequence's arithmetic means. And this means, no pun intended, that I'm looking for terms that when filled in is going to make this an arithmetic sequence. So, that last term is actually very vital. Since 9072 happens to be the fifth term of the sequence, and I have an explicit formula, I can use the value of n being 5 and plug those in so that I know that my last term, 9072, has to equal the first term, 7, plus 5 minus 1. Remember, you're going to be adding the same difference 4 times the difference that you don't know. And we can use that to figure out what the difference is. So what I did is I subtracted 7 from both sides, and then I'll divide both sides by 4. And you find out that my common difference is 2266.25. With the common difference now computed, I can take a new approach when figuring out the different terms. I can now go back to a recursive approach. I have the first term, it's 7. I can add the common difference of 2266.25, and that will establish the second term, which is 2273.25. Why not continue the recursive approach again? Take the value we just figured out, add the d, come up with 4539.5. Do it a third time. We take the third term, add it by the common difference, come up with the fourth term, 6805.75. The best part is we can even confirm this because when we add the fourth term by the 2266.25, we should come up with the fifth term of 9072. We did, it worked, we've got the right numbers. And they are 2273.25, 4539.5, and 6805.75. Let's redo the same sequence, but this time find its geometric means. Therefore, we're going to need terms that will produce a geometric sequence. 9072 is still the fifth term. So if we take the explicit formula for a geometric sequence and substitute 5 in for n, we can say 9072 equals 7 times the common ratio, which is r, raised to the fourth power. If we need to isolate the r, first divide both sides by 7 and say 1296 equals r to the fourth. Since we're solving for the common ratio r, and r is a base in this equation, we will need to take an nth root, specifically the fourth root of both sides. But the fourth root is an even root, and even roots we have to watch out for that we make sure it's a principal root. So when we take the fourth root of both sides, we're going to need an absolute value around the r. Now the fourth root of 1296 is 6, but due to the absolute value of r, when I rewrite it, r could be both positive 6 or negative 6. So what impact does that do when we have two different values of r? Well, let's just start by recursively multiplying each term by 6. So if we go 7 times 6, we'll come up with 42. 42 times 6 will then be 252. 252 times 6 will be 1512. And we can verify that when we go 1512 times 6, we'll come up with 9072. But if we were to multiply by negative 6, the second term would now come up not positive, but a negative 42. Interestingly enough, the third term, negative 42 times negative 6, still goes back to a positive 252. It's the fourth term that could potentially be negative as well, negative 1512. But in the end, we still end up with 9072. So, when you write out its geometric means, you will have to take into account that certain terms may be both positive and negative values, in this case 42 and 1512, with 252 in the middle. You come across a sequence like this one where you do not have the first term and you're asked to find its geometric means. What are you going to do? Well, what I would suggest doing is not worry about that missing first term and focus on the last four terms, because now you can say 1125 temporarily could be the first term and negative 9 could temporarily be the fourth term. You still have an explicit formula. You'll just have to use a value of 4 for your n. This way, g sub 4 will be negative 9. That will equal g sub 1, which is 1125, times your common ratio raised to the third power. Divide both sides by 1125, And if you want to simplify the fraction right away, go right ahead and do so. But you're still going to need to take a root. This time you'll take a cube root of both sides, and the cube root of both sides of negative 1 1/25 works out to be negative 1/5. Pay close attention. You never actually use the absolute values around the r because you were using a cube root. Therefore, there only is one possible answer. With a common ratio of negative 1/5, we can recursively find the missing terms. Let's take 1125, multiply it by negative 1/5 to come up with negative 225. Take negative 225, multiply that by negative 1/5 to get 45, and we'll confirm by multiplying 45 times negative 1/5 to get the negative 9 that we expected. And we can fill in the terms that follow 1125. But we want to find out the term that preceded 1125. So whatever operation we need to use, we're going to have to kind of think backwards. We're going to have to almost find the inverse operation. So if you're multiplying to go forwards, you're going to want to divide 1125 by negative 1/5. Please note that if you don't like doing that, feel free to multiply by the reciprocal of the common ratio. Either way, in both cases, you're still going to come with negative 56/25.